it's going to be at least quadratic, or maybe cubic, and then you got to do synthetic addition. And then the graphs you got to draw tomorrow, you're going to have to draw some with don't have like vertical and horizontal asymptotes. Wasn't there on the review sheet? Okay. And I already told you there, one of the problems is you got to find the distance between a point and a line in space, right? I already told you that.
You did. Yeah, you did.
Yeah, I know it did. So we have to go over lots of things today. Because this test is already hard enough as it is. And then I have one like nice, good fun problem. I'm gonna have a matching problem on there. Like I'm gonna have like a bunch of equations and then a bunch of graphs and gotta match them. This is the first year I actually told you that. Other years I never told them. So hopefully we have time and I'll give you an example. Because some people are just dumbfounded with that. Okay, parametric 4 we're on, right, John? Number 1? Oh boy, we're in trouble. Okay, so this is the particle's position in space. Y equals 4 minus 16, z equals t squared, t is greater than or equal to 0. At what points? Yeah. At what points does this line, or this is not a line because that's t squared, does it intersect this paraboloid? All you gotta do is take these things and plug it in. Do I really have to do this? 2 minus 4t squared plus 4 minus 6t squared equals 4z, which is t squared. You only have an equation in t, solve for t, and then plug it back into here, and then you're done. You really want me to do the algebra? I could have done it already. 4 minus 16t plus 16t squared plus 16 minus 48t plus 36t squared is equal to 4t squared. You see your mistake already? 48t squared minus 64t plus 20 equals 0. Divide by 4. 12t squared minus 16t plus 5 equals 0. Does this factor? So what? 6 and 2, yeah? Because minus 10 minus 6. So t equals either 5, 6, or 1/2. So take these two numbers, plug it in here, and those are the 2 points where it intersects. This is algebra. Okay, B, when t is 1, the particle is at point P. If O is the origin, find the length of the vector OP. So in part B, when t is equal to 1, what are the coordinates of the point? What happens when you plug in 1 for t there? Plug in 1. -2. -2, 1. Okay, so this is point P. Here's the origin, 0, 0, 0. How do you componentize vector OP? Head minus tail. So what happens when you componentize? And then what does this mean? The bars around it. Magnitude. How do you find the length of the three-dimensional vector? The square root of this squared plus this squared plus this squared. 4 plus 4. How many times have you done this one? 3, right? 2, 2, 1. It's a Pythagorean 4-pole. What 4-pole am I going to use tomorrow? 2, 3, 6, 7. Now since I told you that, we're going to use another. 2, 10, 11, 15. Now since I told you that one, I'm going to use a different one. Okay, number 2. Okay, number 2 is the meat of the test, people. There are 8 problems. Going to have 5 of these. 1 matching, 1 find the distance between a line and a point, and 1 where does a line intersect some graph, just like on the last problem on your quiz. That's the whole test right there. I just told you everything. Okay, 2, what's the first one? B. Ooh. Now tomorrow, do you think you gotta know trig identities? You bet your bippy you do. And I'm gonna repeat this again. What do you do when you get stuck tomorrow? Square. Well, try. I mean, that doesn't automatically mean it's gonna work, right? But at least try it, because it bails you out of trouble lots of times. Okay, now, is there an identity for sine t? 2 sine t cosine t. And can you see that if you square the first equation, you're in the money right there, right? So if you square the first equation, you get x squared equals cosine t sine t, which is that right there. And so if you substitute it in, you get y equal to x squared. And then you draw the graph using the dotted line. It's your parabola, except it's thinner, right? So you have this and this, that's 4 out of 8. You want the other 4 points, you gotta tell me how the particle travels on this. So what you gotta do is look at your time interval and just plug in enough numbers so that you can figure out where it goes. So plug in 0. Okay, you gotta give coordinates here. What would be another good number to plug in? 5 over 4? Okay, go. What are we plugging in? 5 over 4? 0, 1 is over here. Okay, well, first of all, if it's not on the graph, you did something wrong. If I plug in pi over 4, you get 1 over root 2 times 1 over root 2, which is 1/2. And you square that, so you get 1 over root 2, 1. 1 over root 2, 1. Oh my gosh. Okay, and then what happens when you plug in pi over 2? 0, 0. So what happens is, okay, so the particle starts here, then it goes over there, and then it goes back there. So it goes whoop, whoop. Yeah.
So you don't need like middle number. You can be fine with 3 numbers.
You plug in whatever you have to figure it out.
So you don't have to use pi over 8.
Oh yeah, okay, go. No, plug in pi over 8 into there. Go. What's cosine of pi over 8? How long is that going to take you to figure that out? You got to use half angle for that. Why not plug in pi over 6 then? At least that's more reasonable. You don't have to use half angle, right? We know cosine pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2, so that's root 3 over 4 square rooted, so you get root 3 over 2. I don't care what you plug in tomorrow, people. You gotta plug in whatever you need to figure out where it goes. So in this problem, it just goes woo, woo. Wait, whatever. Okay, next. C, D, E. Don't put them in alphabetical order. That really looks like you know something. C. Y equal cotangent squared D. Okay, as soon as you see this, what are you thinking?
Square.
I'm skipping to the next problem.
Where?
No. Yeah, cosecant squared minus cotangent squared is 1, right? So square the first equation. And then this minus this is 1. So if you subtract these two equations, you get 1. And then you get x squared minus y, right? You have to know your Pythagorean identities. And then, of course, you solve for y. So y equals x squared minus 1, which is a parabola opening up, shifted 1 unit down. So wooga, wooga, wooga. So I got 4 points right there. You want the other 4 points? So tell me how I travel. So if I were me, I would plug in pi over 6, pi over 2, pi over 6 at the minimum. Okay, so here are your original equations. Plug in pi over 6. Oh boy. Oh boy. 1, 2, comma, 2, comma, 3. So it's up here. How long do I have to wait? Anyway, once you determine the x coordinate is 2, why not just plug plug it in here, you get 4 minus 1 is 3. Because some of you don't even know what cotangent pi over 6 is. It's actually root 3 and you square to get 3, so no matter what. But if you don't like trig, just plug it down. Okay, plug in pi over 2, go. That's easy. Maybe not.
1, 0.
1, 0. You are correct, so it goes here. And then plug in 5 pi over 6.
2, 3.
Yeah, it goes back up, so it goes like this. That's what happens. Oh boy. So tomorrow, at least get the 4 points, because some of you are going to crash and burn on the second half, yeah? At least get the first 4 points. Now, some of you, I noticed on your quiz, you can't get this, so you start plugging in numbers, and then you have like a part of a graph, but that's not going to get you any points tomorrow. That's 0. If you don't get the first part, then the second half is 0 already. You know what I'm talking about? So if you don't get the first 4 points, then it's a fatal error already. So let the crying begin. D. Are we doing D? Y equals D. So were you guys keeping up with the homework, or you just had a jolly holiday? The last several days. What was it, a holiday? Vacation. Okay, did I give a problem like this before? This looks so familiar. It's like, okay, anyway, look. How can I get rid of the t's? What do I do? I'm stuck. Tomorrow, okay, here's you tomorrow. Oh man, I'm stuck. I don't know what to do. What did Mr. Park tell me? Square the equations. Just do it, okay? If you're stuck, just do it, because maybe something miraculous might occur. But then when you square, make sure you square it correctly now. Don't just square each term. You gotta square the whole thing now. So t squared plus 2 plus 1 over t squared. Square the second equation. T squared minus 2. Some of you gotta look at that. Like, how do you get 2? So algebra 1a, people. Now, if I want to get rid of all the t's, do I add or subtract? You subtract, and so you get x squared minus y squared equal 4. See, it bailed you out right there. But you gotta try it. Some of you are gonna get bad homework score, yeah? Okay, so this is like x squared over 4 minus y squared over 4. So you have to put it in a form where you know how to graph, right? So center is at 0, 0, so you go 2 right, 2 left, make the rectangular box. I'm assuming we know this is a hyperbola, right? Or is that a bad assumption? And since the x comes first, this is a left-right hyperbola. So. Okay, I got 4 points right there. See, Tang is, see, she don't have to pay attention because she's all caught up. See how good she is? Okay, now in this problem, if I were me, I would plug in 1, 2, 3, 4, 5. That's what I would do. What would you do? Since it says t is greater than or equal to 1. Okay, plug in 1. Can you do that? Go.
2.
2, 0.
Okay, so the particle starts here. Plug in 2. 2.5. 1.5. Plug in 3. 3 1/3.
2 and 2.
2 2/3. Oh no, that's up here. Oh, so the particle's slowing down then, yeah? Plug in 4. 4 and a 4. 3 and 3 4. Blah, 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 blah. So what happens is, what's happening?
We're slowing down.
Yeah. A particle starts, it goes like this. Does it keep on going up forever?
Yes.
Yeah. And there you go.
Mr. Park.
Yeah.
When it slows down, you can just do the close to the end, and then you just go to the end.
So it's getting closer and closer to infinity.
No, I mean, you do the
How can
time.
you go, first of all, how can you get closer and closer to infinity?
No, I mean, you show it gets slower though with the time things, and then you can just draw the arrow on the screen.
Wait, let me look. Yeah. Okay, next. Oh, here we go. How many people got E? Okay, there we go, because you know why? You guys forgot how to graph rational functions, that's why. I'll give you a hint. Tomorrow, one of them will be a rational function. Okay, now what do I do? What do I do with tangent squared? Because I see a sign there. What do I do with tangent squared? Turn it into sine squared over cosine squared. Oh, that's good because this is x squared at the top, but what about the bottom? If you want to substitute x for sine t, you want to write everything in terms of sine t, so cosine squared is 1 minus sine squared. And then if you substitute in, you get y equal x squared all over 1 minus x squared. Can we get some 2 points at least for that? Because if you don't get this already, just go to the next problem. The one I have for you tomorrow is a little bit better than this. This is kind of babyish, yeah? Kind of baby food. Okay, let's draw the, okay, how do you graph rational functions? Let's do a review. You go through the 4 steps I taught you. What were the 4 steps? X-intercept, Y-intercept, vertical asymptote, horizontal or slant asymptote, right? Okay, x-intercept. When the numerator is 0, what makes the top 0? And if the x-intercept is 0, then does that mean the y-intercept is 0? Yes, because it's a function. Okay, what about vertical asymptotes? That's when the denominator is 0. What makes the denominator 0? Plus or minus 1, so you get x equal. And don't forget to label your asymptote. And what about horizontal asymptote? If the degree of the top and the bottom are the same, you look at the coefficients.
-1.
So y equal -1 is the horizontal asymptote. What would happen if the degree of the bottom is bigger than the top?
0.
That would be y equals 0. What happens if the degree of the top? No, then yeah, we'll just divide. You divide. Oh my gosh. Okay, so how do I know the graph looks like this? Bounce off, and then
Yeah.
what? That's okay. So you draw this, you get 4 points. All is lost tomorrow. Okay, now go back to your original equations. Now, if I were me, I would plug in 0, pi over 4, pi over 2, 3 pi over 4, and pi. That's what I would do. Plug in 0. Go.
0.
You know why the graph bounces off here, right? There's got an even power there. Right? Point. Odd power go through. Even power bounce off. We already learned this, man. Plug in 0. Okay, so the particle starts here. Okay, plug in pi over 4. 1 over root 2. 1. Okay, now what happens when you plug in pi over 2? This becomes undefined. Tangent of pi over 2 is undefined, which means what? It's going to explode and then disappear. So, okay, that's fine. But where does it reappear?
Okay, another point.
Plug in something just to the other side of pi over 2. Think of, no, that's too far. It's got to be like right there on the other side of pi over 2. Well, what is sine of a second quadrant angle? Positive, and tangent. But then you're squaring it. Tangent is, when you're close to the y-axis, tangent is large, second quadrant negative, but what happens when you square it? It becomes super large positive. So where would that be then?
The one over there.
Yeah,
Coming
up
down.
here, so, and then plug in 3 pi over 4, you're right there. plug in pi, and you're right there, you get 2. So this is what's happening. So tomorrow, if it becomes undefined, it's gonna explode out to infinity and then disappear, and then you have to figure out where it reappears. Somebody tell me, okay, here's some learning thing. Somebody tell me, how come the graph doesn't even go over here?
Tangent squared.
Oh, that's okay, that's one reason. That means the y coordinate is always going to be greater than or equal to 0, right? But another reason is, look, x is sine. Isn't sine always between -1 and 1? So you know the x coordinate's always got to be between -1 and 1, and the y coordinate's always got to be greater than or equal to 0. So the graph cannot go over here. Although I'm sure some of you would put it there. Okay, and here we go. Now we're doing number 4.
This part,
Yeah.
so you have to label pi over 2.
How can you okay, come here, show me. Show me where pi over 2 is. No, I want to see it. No, please. It's infinitely far away. It disappeared, it's undefined. Don't have to leave. That's what a joke. 4. Okay, particle talk. Okay, now come on. Okay, now tomorrow I don't know if I'm gonna give you these equations. You're gonna have to write them on your own. Remember I told you? Okay, part A. Are you joking me? Where does this put this graph intersect the ellipsoid? What do I do? What do you think I'm gonna do? Just plug in. We gotta get to the matching part, you know. So 3 minus 2t squared over 6 plus t minus 1 squared over 3 plus 3 minus t squared over 2 equals 1. All you gotta do is plug those in here and solve for t. And then when you get your values of t, you plug it back in here and that's your answer. You guys can finish that, right? Okay, here we go. B. Write the equation of the plane that passes through the point 1, 1, 1, and it is perpendicular to the line. This is a line right here. Okay, so you have a line, and then we want to write the equation of a plane that's perpendicular to this line. Yeah. Oh, that's ugly. Okay, what do you need to write an equation of a plane?
Perpendicular
Vector and a point. Okay, a point is given. How can I get a vector that's perpendicular to this plane? No. This is the equation of the line right
Use
here.
the t things, the t
This
coefficients.
is the equation of the line right here. See, this is what you gotta know, people.
Use the
This is the equation of the line. Tell me, what vector points in the direction of the line? What should I look at? Should I look at the constant?
The t-
Or do I look at the
t
coefficients of t?
coefficients.
50-50 chance.
T
The coefficients of t. And then what about the constant then? What's the significance of the 3, the -1, and the 3? That's a point that it passes through. 3, -1, 3. We learned this already. We learned that. Okay, so this vector points in the direction of the line, but the line is perpendicular to the plane, so therefore isn't this vector perpendicular to the plane? So the equation of the vector then is, the plane, -2x plus 1y minus z plus d equals 0. And how do I figure out what d is? You plug in this point. You guys can do that, right? And then d, okay, here we go. This is what I'm talking about. This problem is on test. You just gotta be able to do it. I did it for you last week. Find the distance between the origin and the line. So here's the line, and here is the point, which is the origin. Find this distance right there. How did I tell you how to do this problem? You make the triangle, right? Remember? This problem is on, I told you this last week. This problem's on the test. Okay, how did you, does anybody remember how to do it? Okay, what?
We're doing the problem, right? Okay, so you make.
Wait, let me look.
So you use the cross
Okay,
product.
here. Yeah, okay. What you need is, you need this and this. You need those two vectors. That's what you gotta do.
Use the cross product.
Okay, do we know a point that lies on this line?
Yeah.
Yeah, look. See, that's why I gave you this problem, so you know what to look for. Like, we already talked about this. What do I look for a point on the line? Those are the constants right there. So 3, -1, 3. The first problem I gave you this point and that point, right? Okay, then you need a vector that points this way. What is that vector?
The
Right
vector.
there. You look at the coefficients of t. -2, 1, and -1. You have to know what those numbers mean. Okay, so remember what we did last time? Remember I gave you a formula. Does anybody remember the formula? Or are we just going to grind it?
1/2.
No,
Base
no.
times height.
No, that's not a formula, fool.
It's the cross.
Okay, never mind. We're just going to go from scratch then. Okay, so what is this vector in component form then? -3, 1, -3. Okay, these two vectors form the triangle, right? Okay, and remember the area of a triangle is 1/2 base times height. How do I find the area of a triangle formed by two vectors? It's half the length of the cross product. So what you do is you compute the cross product, the ijk across the top, -2, 1, -1, -3, 1, -3. So that's equal to I minus j. Don't forget the minus. Okay, so if you cross out the right column, you get, okay, what goes in here? Saka. I heard my name. Somebody whispered to me the question. What's this? Oh, your voice came funny. -2. What goes there? Tang. Read off your paper. 3. And then what goes there? Sito.
6 minus 3 is 3.
That's wrong.
Just say anything. 8 minus 5 is 3. 12 minus 4 is 8. It's 1.
Oh wait, that divided by 2. I mean divided by u, right?
Okay, so like there. Write it like that if you don't like ijk. That's the cross product of these two vectors. Half the length of that is the area of the triangle. So what's the length of that vector? The square root of this squared plus that squared plus that squared. So 4 plus 9 plus 1 over 2. That's the area of the triangle. But the area of the triangle is equal to 1/2 base times height. So if we can figure out the base, then we can figure out the height. Here's the base of the triangle. Do I know the length of it if I know its components? Yeah, it's the square root of that squared plus that squared plus that squared. So it's the square root of 4 plus 1 plus 1. 2's cancel out. So therefore the height of this triangle, which is the distance between the line and the point, is equal to the square root of 14 all over the square root of 6. But that can be reduced to the square root of 7/3. Wakapa!
Wait. Oh, yeah.
Wait, what? Something exotic about it?
Okay, we're just H. Alright. How do you get the root 6?
Okay, wait. The height of this triangle is the answer to the problem, right?
Yeah.
So isn't the area of a triangle equal to 1/2 base times height?
Yeah.
So if you want to find the height, you just have to find this and this, and that's what we did. Remember we did this problem before, and I said this is on the test. And then we derived the formula. If this is vector u and this is vector v, look. How do you get the answer? It's this divided by that. Now what's this? That's this. What is that? That's the cross product of the two vectors. And then you find the length of it. And then you divide it by this. What is this? That's this. That's the length of this vector. That's the distance right there. If you need that's the formula that I wrote on the board the last time we did this problem. But you got to remember, u is the vector that forms the base, and v is the vector that's not the base of the triangle. And like I told you last time, I wouldn't memorize that formula. I would just figure it out. Okay, this problem is on the test. I believe it's the second to the last problem. Or is it the third to the last problem? It's one of them. And the last problem, okay, we got time. The last problem on the test is matching. This is the fun part. So I'm going to give you a bunch of equations of the parametric equations and a bunch of graphs, and you just have to match them. Now, last year, some people didn't know what was going on, so they just put C, 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 C. And then they got 1 out of 8 correct. Or, well, I forget how many I gave. 6? I don't know. So here, okay, let's just, I'll give you some equations. X equal, give me something.
1.
2 cosine t. Y equals 3 sine t. Okay? And then, okay, here, let me give you some graphs. Okay, let me give you some graphs. Okay, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So, woohoo! Circle. Oh, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Woohoo! We live. Okay. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Woohoo! 2 hyperbola. Okay, which one of these will give you, which of these graphs can be drawn from that equation? Now, if you want to, you could actually get rid of the t and try to figure, but you don't even need to do that. Just use common sense.
You look
Yeah, that's because you saw for t, but what if I give you something strange here? Like there will be. Yeah, plug in points. So for example, if I plug in t equals 0, what do you get? What if I plug in 0 for t? What do you get? You get the point 2, 0. So that means the graph has to pass through the point 2, 0. Okay, all of it, so you can't eliminate. No, why would I make you get it just on the first one? You gotta do some work. Okay, now let's plug in something else. What happens when you plug in t equal pi over 2? 0, 3. So which of these graphs pass through the point 0, 3? Hey, only that one, so that's the answer.
Wait, we can solve it that quickly?
It's matching full, I mean lump. Matching.
Can you give a hard
No. You're lucky I'm even telling you this. All the other years, I never told them anything. I just sprung it on them. And that's why they had to go C, 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 so they can guarantee 1 correct.
Wait, they actually.
But even that's not good because there's more equations than there are graphs. Or there's more of one of them than the other. Let's just put it that way.
Some of the graphs are repeated. If there's
No,
no
some of the things are not.
Mm.
Okay, never mind. There's the same amount. There, does that make it easier? Do you see what I'm doing? Do not try to solve the equations. Just plug in numbers and figure it out. You know what I'm talking about? Can you do this one? So I gave you the secret now. I expect everybody to get this problem. You better nail it.
You gave this one?
Huh? No, I don't think there's not going to be any half-angle identities this year.
Are they double angle identities?
Okay, but I'm thinking, okay, wait, I didn't really make the test since we got a few minutes. Since you said half-angle, this just sprang into my mind.
This morning,
Y equal, no, X equal cosine T. Y equal tangent, yeah! See, I just thought of this. That's a fantastic problem right there.
Trent, why would you
I just thought of it now.
No,
there's no double angle.
no, don't bring it up. No.
Double angle get plenty.
Oh, I mean half angle.
Wait, let me look.
There's a part quiet.
Trent.
Wait, that's it.
Okay, look, we got 2 minutes. So, okay, half angle for tangent. There's 3. 1 minus cosine over sine. Sine over 1 plus cosine, or plus or minus the square root of 1 minus cosine over 1 plus cosine. Which one do you think we're going to use here?
The cosine
Oh,
one.
plus or minus the square root of 1 minus cosine over 1 plus cosine. And then you got to square it. But that's easy because look, if x is cosine theta, you plug it in, you're just going to get 1 minus x over 1 plus x. It's squared. Who said square root? You square it. The last time I looked, if you square a square root, the square root disappears. Okay, now how do you graph that? Okay, we got 1 minute. Go through the 4 steps if it's a rational function. And you will have a rational function. X-intercept, 1. Y-intercept, 1. Vertical asymptote, x equal -1. Horizontal asymptote is the degree of
-1.
You look at the coefficients, y equal -1. And so we got, oh, dotted line, monkey. Dotted line. And then just plug in numbers after that. Well, can you even get that far? That's the thing. How come we don't remember our identities? I don't understand it. Sito, help me to understand. Okay, no, let's ask a question.
If you were to look at the graph and know that x can't be bigger than 1, or x has to be between -1 and 1.
Right.
you
Okay,
have
look,
to draw
see
the
those?
dotted-
Exactly. X has to be between -1 and 1. Y, since you're squaring it, gotta be greater than or equal to 0. So the graph only gotta be like right
So you
there.
don't have to draw the rest of it.
Well, how do you know it goes on the whole thing? Well, how do you know it just doesn't go like this? Whoop, stop. How do you know it keeps on going?
No, but
Yes, but the graph is restricted to between.
So do you have
Here
to
and
draw
there.
the dotted line stuff?
You're right, yeah.
Outside of that?
Yeah, so this part here will not come into play.
So do you have to draw it though?
Yes, because what if I give you a different time interval? What if I give you from 0 to pi over 3? Yeah, but see, but that's thinking. That's exactly how you gotta think. Okay, the bell's gonna ring already. Okay, so next week Wednesday is the last test of the quarter now. Next week Wednesday, the test is on combinatorics. Well, we're gonna start learning it on Thursday. Oh, no. Yeah, because those are the reserved days for math and English. Just on Thursday. Watch the video. Well, what field trip is this, Al? What field trip is this?